The second lesson from Unit 1 is on scientific notation. Often when we are recording data, scientists will encounter very big or very small numbers. To make recording data easier, scientists will write numbers in scientific notation. Okay, so for example, the Hope diamond contains about, well, let's just take a look at this number here, 460, and if we work our way backwards, right, thousands, millions, billions, trillions, quadrillions, quintillions, sextillions. This is 460 sextillion atoms, roughly. Okay, that's a huge number with a lot of zeros. It's very easy to make a mistake when writing that number. It's also not practical to write this out. It just takes up so much space, and we're just writing out a bunch of zeros for no reason. So instead, okay, this is the format that we use, okay, is the some coefficient times 10 to some place value, okay? That's the correct way to write these numbers. So instead of writing this big long number like this, okay, we write it out as 4.6 times 10 to the 23rd. The Hope diamond, by the way, is at the Smithsonian in Washington, D.C. It's a very, very pretty blue diamond, if you've ever had a chance to see it. But that's a lot of atoms in that diamond. It's a very large diamond, but even then it's got like just tons and tons of atoms. So it's much easier to write it as 4.6 times 10 to the 23rd than write, 4, 6, and then a bunch of zeros, 20 zeros or so after that. We're first going to take a look at the rules for how to do this and a couple of examples, and then we'll do these two up here. Okay, so the rules are, number one, if there is no decimal point in the number, add it where it belongs. Okay, so if your number doesn't have a decimal, put the decimal where it should be. So that's rule one. Rule two, move the decimal to create a coefficient that is between 1 and 10. It can equal 1, but it cannot equal 10. So for example here, we got two examples. Example number one, we've got 2,500. Our decimal normally would be right there, right? We didn't have it, so I had to do rule one, which was added in. Then I need to move that decimal to create a coefficient that is between 1 and 10. It can equal 1, but it can't equal 10. Okay, so I'm going to move it 1, 2, 3 places over, okay, and we'll put it in blue to make it a little bit different. All right, so now my new coefficient is there. So instead of writing 2,500, okay, I'd write 2.5, and it's going to say then, times 10 to some value, right? This is the coefficient. If we go back to that formula on the previous page, it's going to be 2.5 times 10 to some number, okay? If we do the same thing here in example number 2, we don't have to put the decimal in the number because it's already in here. However, we do need to move it because right now this is not between 1 and 10, right? This is 0.0 something, so it's not between 1 and 10. We need to move it just like we did on the previous one. So if we take the number where it is, the decimal where it is now, and move it 1, 2, 3 this way, okay, I still get the coefficient of 2.5. Let me put that new decimal point in blue like I did before. All right, and this comes out to be 2.5. Now, that's just to move the decimal. Okay, we're not done here. This is just to get us a coefficient between 1 and 10. Okay, it's got to be less than or equal to 1, or sorry, greater than or equal to 1, but less than 10. Okay, that's what we're saying there for this coefficient. All right, so once we've done that, we've got a coefficient between 1 and 10. If the decimal moves to the left, the exponent becomes positive that many spaces. If the decimal moves to the right, it becomes negative that many spaces. So with example 1 here, okay, the decimal moved, whoops, we're going the other way. Starts there, 1, 2, 3, so it went 3 places to the left. All right, so my coefficient is still 2.5, and it's going to be times 10, and since it moved to the left, the decimal moved left, and it moved left 1, 2, 3 times, right? It started here, so it's moving 1, 2, 3 times over. Okay, it's going to be positive that many numbers. So that's 2.5 times 10 to the third. All right. If we do the same thing to the second one, though, and it's going in the opposite direction, right? It's going 1, 2, 3 places that way to the right. And if we read the rules there, we can see that, right, moving to the right is going to make it negative. So I end up still with 2.5 times 10, but instead of positive 3 like the previous one, it's moving to the right, so that's going to be negative 3. Okay, I'm going to do this one with you up here, and then I want you to try this one on your own. So we have 321,000. Okay, step 1, we need to put a decimal into the number, so we're going to go ahead and do that, right? That would fall right there because it's not currently there. I then need to move the decimal in a way that's going to get me a coefficient between 1 and 10. So it's going to have to go this way. It's going to have to wind up over here, and it needs to wind up between this 3 and the 2. So it's going to move 1, 2, 3, 4, 5 places that way, and the new decimal point ends up right there. So my coefficient is 3.2, and then it's going to be times 10, right? This part's always going to be there. And it moved left, correct? So it moved to the left. It moved to the left 5 times, so it's going to be positive 5, okay? Why don't you go ahead and try this example here on your own, see how you do. Okay, now for a couple of rules on how to do adding and subtracting, and then multiplication and division using scientific notation. This is ideal because then we can avoid having to use a calculator, or you can try to avoid using a calculator doing this. So, for example here, for addition and subtraction, let's say we've got two numbers. We got the 7.35 times 10 to the second and 2.43 times 10 to the second. Let's say we want to add them together. As long as the powers of 10 are equivalent, so here they're both squared, right? They're both to the second power. You can add or subtract the coefficients. So all I need to do here, instead of typing into your calculator 7.35 times 10 to the second plus 2.43 times 10 to the second, what you can just do is type in 7.35 plus 2.43, and that becomes your coefficient, right? Okay, so I'm just taking this number and this number, adding them together to get this one. Notice my exponent stayed the same here. We'll see an example here in a minute of how this might change, but generally speaking, this is the rule to follow. Okay, the same thing is going to be true for subtracting numbers written in scientific notation. 7.35 times 10 squared minus 2.43 times 10 squared. Okay, all you have to do is just type those coefficients into your calculator. 7.35, okay, this one right here, minus 2.43, and we get 4.92, and then it's going to be times 10, and I just keep the exponent the same. Okay, so that's how you do that. So that's the rule there for adding and subtracting with scientific notation. Notice though, right, remember the coefficients, not the coefficients, the powers of 10 need to be equivalent. All right. So we just saw the addition and subtraction rule. What about the multiplication and division? When multiplying or dividing, perform the math on the coefficients, then perform the math on the powers of 10. Okay, so we'll see how this works. All right. So we've got this number, 4.6 times 10 to the 23rd. That was that number we saw back there on the second slide of this lesson with the atoms in the Hope Diamond. 4.6 times 10 to the 23rd times, and then my other number, 2 times 10 to the negative 23rd. All right. So what happens here? Well, I perform the math on the coefficients. Okay. I have 4.6, and I have a 2, and I have a multiplication sign, right? So those things there, 4.6 times 2 is going to give us 9.2. So that's how we wind up with the first number, okay? Then we have to deal with the, I keep saying coefficients, the powers of 10. And this is going back to your algebra skills. 10 to the 23rd, okay, times 10 to the negative 23rd. I'll do this in a different color, right? 10 to the 23rd times 10 to the negative 23rd. All right, what we do there, you might remember, and this is how we get this final value, is if we are multiplying with powers, okay, we add those numbers together. So 10 to the 23rd times 10 to the negative 23rd, we take the 23 plus, because this is a multiplication sign, negative 23. So 23 plus negative 23 is 0. So this works out to be 9.2 times 10 to the 0. Right? 10 to the 0 is just 1, so that number is really just 9.2. Okay, and we're going to see the same thing happen with division, except instead of adding the exponents together, we are going to subtract them. All right, so we're going to do this math just the same. 4.6 and the 2, the coefficients math first. 4.6, and this time I'm dividing, right? I got my division bar here. 4.6 divided by 2 is 2.3, right? Don't need a calculator necessarily to do that. And then I look at the math here on my exponents. I've got 10 to the 23rd and 10 to the negative 23rd, and since I'm dividing, it's going to be 23 minus negative 23, right? Which is really just 23 plus 23, so that's going to be 46. So the answer to the second one is 2.3 times 10 to the 46 because I'm subtracting exponents with this division here. Okay, so that's just going back to some of your algebra skills. 4.6 times 10 to the 23rd divided by 2 times 10 to the negative 23rd. Gets us 2.3 times 10 to the 46th. Okay, and finally, before I give you a couple of examples to try on your own here and check to see how you're doing, we need to be careful with some of our final answers. So it's easy if we're just doing, automation here and not thinking about what our answers look like, it's easy to miss this. So there's 4 examples here for us to look at. Example 1, 7.5 times 10 to the 4th plus 3.0 times 10 to the 4th. Okay, so it's an addition subtraction type of problem. The coefficients are 7.5 and 3. My exponents are 10 to the 4th and 10 to the 4th. Those are the same, which means I can add this. However, when I add this, I get 10.5 times 10 to the 4th. Okay, and what's wrong with that here is that my coefficient, right, you must remember, okay, has to be greater than or equal to 1 or less than 10. Well, here it's 10.5, so that won't do. So what I need to do is actually move the decimal back over. All right, so if I move this to the left one time, my new coefficient is 1.05 times 10. Now it moved to the left, which means it becomes more positive. It moved to the left one time. So this isn't 10 to the 4th anymore. We're going to add 1 to that number, so this is 1.05 times 10 to the 5th. Okay, so just be careful. If you get a coefficient in your answer that falls outside of these bounds, okay, you will have to adjust your answer to be in proper scientific notation. Okay, let's look at the second example, 2.5 times 10 to the 4th minus 2.3 times 10 to the 4th. Again, the exponents here, 10 to the 4th, 10 to the 4th, those are equal, so I can subtract it. 2.5 minus 2.3 is 0.2, and then it would be times 10 to the 4th. But just like we saw before, right, my coefficient must be greater than or equal to 1 or less than 10. Well, here it's less than 1, right? So I need to move my exponent to the right one time. Okay, so I get 2 now times 10. I move to the right one time, which means my exponent is going to subtract 1. So this is now 2 times 10 to the 3rd is the correct answer there for that one, okay, in proper scientific notation. All right, so some multiplication and division examples. So we're going to do the math on the coefficients, then we'll do the math on the exponents, and we'll see what's kind of funky about this one. Okay, 4 times 3, so that means my coefficient here is 12, which immediately should show you something's kind of funny. We're going to have to change it. And then 10 squared times 10 to the 3rd. We're going to add those exponents, so we get times 10 to the 5th, right? But as we just saw, we can't have a coefficient that is greater than 10 or less than 1. So what I need to do is move, the decimal will normally be here. I need to move it to the left one time. So I get 1.2 times 10 to the 6th, okay, is the correct answer there for that one. And in the division example to finish us off, 3 times 10 to the 3rd divided by 4 times 10 to the 2nd. 3 divided by 4 is going to be 0.75, right? We can do all this without a calculator. 0.75 times 10. Okay, so it's division. 10 to the 3rd divided by 10 to the 2nd. 3 minus 2 is 10 to the 1st. Okay, my coefficient here is in an improper format, so I need to adjust it. I'm going to move that to the right one time, and my new coefficient is 7.5 times 10. Okay, since it's moved to the right one time, we're going to subtract 1, so it becomes times 10 to the 0. And yes, this is still proper scientific notation. Proper scientific notation. Okay, so if you get a number, even though it's times 10 to the 0, right, if you plug that into your calculator is just going to say 7.5. Okay, because this is really 1. 10 to the 0 is 1. But if I ask you for an answer in proper scientific notation, make sure you include that times 10 to the 0, because that should be there. Okay,